What if I told you that by 2027, the United States is deploying artificial intelligence systems, capable of predicting and subtly influencing extreme weather patterns? Not through science fiction weather control towers, but through sophisticated cloud seeding operations, guided by predictive algorithms that identify optimal intervention windows with unprecedented precision. Welcome to our channel, Tomorrow Intelligence.
Overwhelmed by AI? Afraid of being left behind? You're not alone. But the answer isn't fear, it's fluency. Mastering ChatGPT is your complete roadmap, from your first prompt to expert-level AI collaboration. Whether you're a student, entrepreneur, or lifelong learner, this guide turns ChatGPT from a mystery into your digital partner. No coding, no jargon, just clear, step-by-step mastery. Inside, you'll learn how to write powerful prompts that get accurate, creative results, and real-world strategies to save hours on writing, research, and learning. Plus, advanced techniques used by professionals and how to avoid costly mistakes. The paperback is $14.99. Hardcover, $24.99. Right now, get it for just $6.99. Less than your weekly coffee. For that, you get a lifetime skill, speaking the language of the future. The future doesn't belong to those who fear AI. It belongs to those who master it. Don't wait. Your first expert-level conversation starts with one click. Scroll up, link in bio. Grab Mastering ChatGPT on Amazon today. Your AI fluency begins now.
This capability isn't Hollywood fantasy. It represents the genuine frontier of climate intervention. For decades, humanity dreamed of guiding the rains, but only now do we possess the computational power to attempt it with precision. At this frontier, machine learning models trained on petabytes of atmospheric data can now forecast storm development pathways days in advance. These aren't mere guesses, they are hyper-local probabilities refined by every satellite pass and sensor reading. These systems can now recommend targeted cloud seeding operations to reduce hurricane intensity or redirect drought-breaking rainfall toward agricultural regions that need it most. It's about optimization, not just intervention. Yet critical clarification is essential upfront. No system currently controls weather in the sense of creating or eliminating storms at will. The reality is more nuanced and far more scientifically grounded. What actually exists in 2027 are experimental programs, primarily under NOAA's Atmospheric Modification Research Initiative and DARPA's Climate Resilience Program, pioneering a new era of climate management. These programs use AI to optimize traditional weather modification techniques like silver iodide cloud seeding, making interventions more effective while minimizing unintended consequences through rigorous simulation. During Hurricane Franklin's approach to the Gulf Coast in August 2026, the world witnessed a turning point. As the storm gathered strength, an AI system called AETHER went to work. AETHER, Atmospheric Hazard Evaluation and Targeted Environmental Response, analyzed real-time satellite data, ocean temperature profiles, and atmospheric pressure gradients in a continuous feedback loop. The system identified a narrow 3-hour window where cloud seeding could disrupt the storm's eyewall formation. This was a surgical strike against a chaotic giant. Mission Command received specific flight paths for NOAA's modified C-130 aircraft. Every turn and dispersal point was calculated by AI to maximize the impact of every gram of silver iodide. As the aircraft dispersed particles into strategic updraft zones, the goal was clear: weaken the storm's structure before it could reach the shore. It was a race against the atmosphere itself. The results were statistically significant, a 12% reduction in maximum wind speeds before landfall. This modest shift was enough to change the outcome for thousands. This intervention prevented an estimated $800 million in additional damage. It proved that AI doesn't need to stop a storm to save a city. It just needs to nudge it. This represents a move beyond random cloud seeding toward precision atmospheric surgery, guided by AI that understands complex meteorological systems as interconnected networks. The technology leverages existing infrastructure, satellites and radar, but enhances them through AI that processes data at speeds impossible for even the most experienced human forecasters. Machine learning can now identify subtle precursors, temperature differentials of less than half a degree, that signal optimal intervention opportunities invisible to conventional analysis. The impact extends beyond storms. During the 2026 California drought emergency, AI-guided operations over the Sierra Nevada increased snowpack accumulation by 18%. This provided critical water reserves for the following summer, sustaining agriculture and communities through one of the harshest dry spells on record. It is adaptation in action. However, we must remain humble. Atmospheric systems remain chaotic and unpredictable, with intervention effects often indistinguishable from natural variability without deep analysis. The 2027 landscape presents not a finished weather control capability, but a rapidly evolving research frontier where scientific curiosity meets urgent climate needs. Claims of AI controlling weather circulating online stem from misleading demonstrations, marketing exaggerations that undermine legitimate progress by setting impossible expectations. Understanding this nuance separates genuine atmospheric science from viral misinformation. It allows us to appreciate real breakthroughs without succumbing to sensationalist narratives. As we move forward, the goal isn't to play God with the weather, but to use every tool at our disposal to protect our planet and our people in an era of unprecedented change. The frontier of climate intervention is here. It is precise, it is data-driven, and it is just beginning. Thank you for joining us on this journey into the future of atmospheric science. To understand the AI frontier, we must look back. The dream of weather control began in earnest in 1946 at the General Electric Research Laboratory, where researchers discovered that dry ice and silver iodide could trigger precipitation. These early Project Cirrus experiments were the first steps in a journey that would span nearly a century. In the 1960s, Project Storm Fury attempted to weaken hurricanes by seeding the eye wall. While the results were inconclusive at the time due to the overwhelming chaos of natural systems, the data gathered during these missions forms the bedrock of the machine learning models we use today. We are standing on the shoulders of giants. But with this power comes profound ethical questions. If one nation steals the moisture from a storm system to end a drought, what happens to the neighboring country downwind? The concept of rain wars is no longer purely theoretical. International treaties like the 1977 Environmental Modification Convention are now being rewritten for the AI age. Legal frameworks must now define who owns the sky. Is atmospheric moisture a global common or a national resource? AI helps us model the downwind effects with 90% accuracy, providing the data needed for fair international agreements and preventing climate-based conflicts before they begin. Looking forward, the hardware is evolving alongside the software. We are moving away from piloted C-130s towards swarms of autonomous AI-driven drones. These units can stay aloft for days, loitering in the upper atmosphere to wait for the exact millisecond an intervention opportunity arises. Ultimately, this technology is a tool for global resilience. By stabilizing rainfall and reducing the peak intensity of storms, we can provide a safety net for the world's most vulnerable regions. It is a testament to human ingenuity, using our most advanced machines to protect our most ancient systems. To reach this level of precision, the AI engine requires an unprecedented amount of training. We are talking about feeding models decades of historical weather data, every pressure shift, every temperature spike, and every wind gust ever recorded. By simulating millions of what-if scenarios, the AI learns to recognize the subtle whispers of the atmosphere long before they become a roar. But data alone isn't enough. The AI needs real-time eyes on the ground. A global array of sensors, from deep-sea buoys measuring ocean heat to high-altitude balloons tracking stratospheric winds, provides a continuous pulse. This Internet of Atmospheric Things ensures that the AI's recommendations are grounded in the absolute reality of the current moment, minute by minute. Let's look closer at the 2026 California emergency. The AI didn't just seed clouds, it identified specific moisture corridors within the Sierra Nevada range. By timing the dispersal to match the exact cooling phase of the storm, researchers were able to squeeze out every possible drop of water, resulting in that critical 18% snowpack increase that saved the state's agriculture. The next great challenge is managing atmospheric rivers, vast plumes of moisture that can cause catastrophic flooding. AI models are now being developed to slightly redirect these rivers, nudging them away from vulnerable urban centers and toward depleted reservoirs. It is a delicate balance of protecting against disaster while capturing life-giving water. Success in this field relies on a unique partnership between public institutions like NOAA and the private tech sector. While government provides the oversight and the ethical framework, private enterprise brings the raw computational speed and innovation. This collaboration is the engine driving our transition from weather victims to weather stewards. Trust is the most valuable currency in climate intervention. That is why transparency is paramount. By making the AI's decision-making process and the results of every mission open source and peer-reviewed, we ensure that the global community can see exactly how and why these interventions are occurring, building a foundation of scientific trust. We are building toward a future of climate resilience. A future where a drought doesn't mean a failed harvest and a hurricane doesn't mean a destroyed community. We are using the most advanced technology ever created to preserve the natural systems that have sustained us for millennia. It is a vision of harmony between machine and nature. The frontier is no longer a distant hope. It is a present reality. As we refine these tools, we are writing the next chapter of the human story, one of adaptation, innovation, and hope. Thank you for exploring the precision of weather modification with us. The sky is no longer the limit, it is the new beginning. Behind every line of code and every satellite reading are people, scientists dedicated to understanding our world and communities striving to adapt. This is a human endeavor powered by artificial intelligence but guided by our shared values of safety, sustainability, and stewardship. As we stand on the threshold of this new era, the question is no longer if we can intervene, but how we can do so wisely. Together, we are not just forecasting the future, we are building it. Join us as we continue to push the boundaries of what's possible. The AI frontier is just the beginning. The genuine implications of AI-enhanced weather modification emerging in 2027 extend far beyond technical capability. They reach into profound geopolitical, environmental, and ethical territories that demand careful navigation before widespread deployment. Climate adaptation applications represent the most promising near-term use case: coastal communities facing intensifying hurricanes. These cities could reduce storm surge impacts through targeted eye-wall disruption, saving lives and infrastructure, while agricultural regions suffering prolonged droughts might secure critical rainfall through precision cloud seeding. During 2027 trials in the Midwest, AI-guided hail suppression operations reduced crop damage by 23%. This demonstrated economic benefits that could justify massive investment despite the significant intervention costs. Yet these benefits coexist with dangerous misuse potentials. Nations could weaponize weather modification by redirecting rainfall away from adversary territories or intensifying storms approaching enemy coastlines. These scenarios seem dystopian, but become technically plausible as the technology matures in the coming years. The 1978 ENMOD Treaty prohibits hostile environmental modification, but verification remains nearly impossible. When weather naturally varies, it creates dangerous ambiguity where nations could plausibly deny responsibility for intervention. China's expanding weather modification program, which already covers over 55% of its territory, is growing rapidly. It includes AI-enhanced systems that could theoretically influence monsoon patterns affecting neighboring countries. This raises concerns about transboundary impacts that currently lack clear international regulatory frameworks. The fundamental challenge lies in attribution, when a modified storm causes flooding in one region while preventing drought in another. Who bears responsibility for the negative consequences that arise from these planetary-scale interventions? Legal scholars debate whether weather modification constitutes shared resource management or sovereign territorial control. This has massive implications for international liability and the development of compensation mechanisms. Regulatory frameworks scramble to catch up. The WMO's proposed weather modification guidelines would require transparent reporting, while the European Union considers mandatory environmental impact assessments for any cross-border atmospheric operations. These protections are essential because weather modification effects cannot be contained within national boundaries. Rainfall redirected from Texas might enhance flooding in Louisiana, creating domestic legal conflicts. Public acceptance remains another barrier. Even if the science is sound, communities may reject interventions. Often, this is due to distrust of government motives or fear of the unintended consequences of playing God. A 2027 Pew Research study found 68% support weather modification for drought relief, but only 29% approve of hurricane modification. This paradox highlights the tension between localized benefits and the systemic risks that we still don't fully understand. Insurance markets explore cautious applications, offering premium reductions for communities in hail suppression programs. But major carriers avoid coverage for intervention-related damages due to these profound attribution uncertainties. Philosophical questions intensify around planetary stewardship. If we can influence weather, do we have a moral obligation? Or does such intervention represent dangerous hubris that could destabilize Earth's natural systems further? Early studies suggest this mindset influences policy, with some prioritizing technological fixes over emissions reductions. This is a dangerous distraction from addressing the root causes of climate change that we must face. By late 2027, the field stands at a critical inflection point. Technical progress accelerates through improved AI. But societal readiness lags due to unresolved ethical dilemmas and the massive governance gaps we see today. Responsible development demands prioritizing transparent, defensive applications with strict oversight over covert uses. We must implement robust monitoring systems to track effects and establish norms preventing unilateral actions. The future of weather modification depends not on computational power, but on whether humanity develops the wisdom to govern, recognizing that some natural systems may be too complex for safe manipulation, regardless of our technical feasibility. Understanding this tension between what we can do and what we should do separates thoughtful engagement from naive optimism. The ultimate question isn't whether AI can influence weather, but whether we possess the collective wisdom to wield such power. If you found this responsible exploration of AI-enhanced weather modification insightful and valuable, please subscribe to Tomorrow Intelligence. Like this video to help others separate genuine atmospheric science progress from sensationalist claims about weather control AI. Share with fellow climate scientists, policymakers, and technologists who understand that these technologies demand the wisest governance. Hit the bell icon to receive notifications whenever we publish new content examining how AI, climate science, and stewardship converge. Tomorrow Intelligence delivers deeply researched analysis that distinguishes verified scientific advancement from misleading marketing narratives. Join our community of forward-thinking innovators, building ethical frameworks alongside technological capabilities. Thank you for watching.